We continue review for the midterm exam. Compute the linear correlation coefficient between the two variables x and y. So we have x equal those values and y equal these values. We use calculator for this problem. So first we hit stat and go to edit and enter the numbers on the list. If we need to clear the list, let's say if there's something there and we want to clear it, highlight it, hit clear and enter. Right, 2, 3, 5, 5 and 6. Then go list to 1.3, 1.6, 2.1, 2.2 and 2.7. Right, so enter x in list 1, 1, list 2. And then second mode back to home screen. And I will do that again, but this time we'll calculate the linear regression. X is list 1, y is list 2, and we just calculate. Right. If you're using the TI-83 calculator, when you hit stat and go to linear regression, that's what we have. In that case, we just hit L1 for x, L2 for y, and we calculate the same thing. The problem here is we do not have the R. So to get R, we only need to do this one time on the calculator. Second, number 0, go to catalog and go all the way to diagnostic and turn it on. Wait, okay, right there. Diagnostic on, hit enter again. So it's done. And now we do that the linear regression one more time. And this time we have R is 0.9827. Right, so 0.9837. And R, the closer it is to 1 or -1, the better the linear relation. And so this is 0.983 and very close to 1. So we have the linear relation exists. Once again, if it is close to 1, positive 1, so, and we say positively related. The closer it is to 1, the more positively related they are. If we close to -1, then we have negatively related. And if we close to 0, no relation. So this case, because it is very close to 1, relation exists and exists strongly. Right, next. Find the equation of the least square regression line. So pretty much what we've been doing, and route the values to the nearest 1000. So do that again. Stat, edit. I need to clear the list first. I highlight L1, hit clear, and enter. Clear, and enter. Right. Now enter the x values for list 1, -5, -3, 4, 1, -1, -2, 0, 2, 3, and -4. Right, y, -10, -8, 9, 1, -2, -6, -1, 3, 6, and -8. Right. Second mode, back to home screen, and then we do it again. Statistic, calculate linear regression. X for we use list 1 for X, list 2 for Y, and then calculate. Right. So in that form. Right. And so this is in Y equal to AX plus B. On this particular, A is 2.097 x, and B is negative actually it's plus B. B is negative 0.552, and this is best fit line, so it's not actually the graph of the function, so the estimate, so we put a hat to it. Right. Yeah, so that all we have. Right. Now if we want the equation nicely, hit variable, statistic variable, go to equation, regression equation, and you see we have, that is the equation 2.096. Yeah, times x plus negative 0.552. Right, so that's the equation. Right, next, the data below are ages and systolic blood pressure. Right, so we have that information, and the question here is find the least squared regression, so that's what we've been doing, and predict the pressure if the A is 60. Notice that 60 is not, it's one of the points, so we're going to predict based on the equation that we come up with. Right. Now with this H, we predict the pressure, the blood pressure. Right. So do the same thing. Just clear the list first. Now enter the numbers. 38, 41, 45, 48, 51, 53, 57, 61, 65. I type this with the keyboard, so that's faster than typing. 116, 120, 123, 131, 142, 145, 148, 150, 152. Right. And then second mode, back to home screen, and then stat, calculate linear regression, L1 for X, L2 for Y. Right. So we have the equation Y hat equal to 1.49 X plus 60.46. Right now we know it's going to be this already. Now we will predict when X equal to 60. And we just put 60 in the equation and do that. So this should be easy. first we let 60, hit 60, and the STO key here, let's store into X. And then we evaluate this equation. Remember, this equation is stored in the calculator already. Hit variable, variable, and then go to statistic, equation, regression, equation, right, it's there. X equal to 60 already, so yeah. And we have Y hat is equal to 149.7. And the set round is to the nearest whole number. That's 150. Right. So we'll just store any values into X and then evaluate the equation. Variable, statistic, equation, and that equation we evaluate. Right. That's what we have. Right, next, which of the following probabilities for the sample points A, B, C could be true if A, B, and C are the only sample points in the experiment? Right, so now just properties that probability of any event have to be less than equal to 1, greater than equal to 0. So probability have to be between 0 and 1. 0 is never happened and 1 is always happened. So because of that, this is not going to be the answer because of the negative. Right. Next. Next. If we have only A, B, and C, A, B, and C are the event, the sample point, then the probability of A plus probability of B and plus probability of C must be equal to 1. For example, if we toss a coin, whether it's a fair coin or not, the probability of getting head plus the probability of getting a tail should be 1. When they add up together, we might have 40% of getting the head or 60% getting the tail, but the total must be 1. So in this case, this add up to 1. 1.4, 1 over 4 plus 1 over 4 plus 1 over 4. They don't add up to 1, so it's not going to work. 1/8 plus 1/9 plus 1/5 is not going to be equal to 1. So only 1/3 plus 2/3 is 1. And in this case, all the probability of the sample points, the only sample point, only sample points, then it should be equal to 1, and it is. Right, now more on probability. Use the spinner below to answer the question. Assume that it is equally probable that the pointer will land on one of the 5 numbers. Right. Find the probability that the arrow will land on an odd number. So in this case, the spinner or the sample space have 5 numbers. And we have 5 numbers. Now in this event, we want an odd number. Being 1, 3, and 5. And the number of elements in the event, 3 of them. And fundamental probability, we just count how many we have in the set E divided by how many we have in the set S. So there are 3 out of 5. So that's the basic probability. Next, a single die is rolled twice. So first and then second. The set of 36 equally likely outcome is given as below. So we have those. Find the probability of getting two numbers whose sum is greater than 9. So greater than 9 meaning it could have to be 10, 11 or 12. If we have two dice, maximum we have is 12. Right. So first of all, we have 36 equally likely outcome. And we can count them. But the sample space have 36 outcomes. And out of those, how many of them actually greater than 9? So greater than 9 could be, let that be the event E. We can list them if we want to. Greater than 9 should have to be 10, 11, or actually 10, 11, or 12. So 10, 11, or 12 here. That is 10 and 11. And there, 10. Every other case, the sum add up to a number less than or equal to 10. So only those numbers I underline will give us the sum equal to 10. So 4, 6, 5, 5, and 6, 4. Those will give us the sum equal to 10. Sum of 11, we have 5 and 6. Or 6 and 5. And then sum of equal to 12, we have only one case, 6, 6. So in this case, in this event, we have 6 possible outcomes, and the probability of getting event E, which is a number, the sum is greater than 9. Oops, the sum is greater than 9. We have how many of the event 8 divided by the number of elements in the outer sample space. 1/6. Right. So pretty much we just count. The below table show the probability generated by rolling one die 50 times and noting the up phase. What is the probability of getting an up phase? So an odd up phase. So this is odd 1, 3, and 5. And those are mutually exclusive, meaning there's not overlapping. Either you can get a 1, could be a 3 and a 5. You cannot get 3 and 5 or 1 and 3 at the same time. So in that case, we just add them. Probability of 1, 3, or 5 is 0.22, 0.18, that's 0.18, I mean 0.18, and you have 0.58. Right. So when there's nothing in common, we just add them. Right, next. Probability experiment is conducted with the sample space, so pretty much from 1 to 15. Let event A be 5, 6, 7, 8, and B 7, 8, 9, 10, 11. Assume each outcome is equally likely. List all outcomes A and B. Outcome in A and B. So have to be in both. Notice that there's 7 and 8 in both of the set. So we say A and B. The and here characterize the intersection. And have 7 and 8. Since they have something in common, then we say they are not mutually exclusive. So not mutually exclusive. Mutually exclusive is when there's nothing in common. Since there's something in common, it cannot be mutually exclusive. Another word for mutually exclusive is disjoint. Right. Next is the table lists the drinking habit of some college student. If a student is chosen at random, find the probability of getting someone who is a woman or a heavy drinker. So it's easy. Well, here we're just going to count a woman. It's going to be on this row. And heavy drinker. That is the total, so it doesn't count. And the total. And the heavy drinker, we have 5 and 14. Notice the 14 we count twice. But if we're going to count how many we have, it's going to be 187 plus 21 plus 14 plus 5. Those are a woman or heavy drinker. So if we say A is that event of getting a woman or a heavy drinker, if we select a student at random, so woman or heavy drinker, (187) plus 21 plus 14. (187) plus 21 plus 14. 187 plus 21 plus 14. 222. And then we just divide by the total of 421. So probability of getting event E is 222 over 421. And we have 0.527. Oh, I forgot the 5. Sorry. Yeah. 187, 21, 14, and 5. Zero 0.539. Right, so that is one way to do it. The other way to do it, I noticed that the category woman and heavy drinker, there's some overlapping. So in general, I will write woman or heavy drinker. That's right. Heavy drinker. Equal to probability of woman plus probability of heavy drinker minus probability of both woman and heavy drinker. So woman probability of getting a woman here is 222 out of 421, and getting a heavy drinker here, there will be 19 out of 421, and minus both of them, the overlapping is 14 over 421. Of course, combine this fraction, we should get the same thing, 227 over 421. Right. So either we just count how many we have, or we use the formula, and the formula here is P of A or B, P of A plus P of B minus P of A and B. So this particular, this is what we have. Right, more on probability. A probability experiment is conducted in which the sample space, okay, from 2 to 12. Let's count how many we have. Doesn't matter the question. We'll do that later. Let event 8 be 5, 6, 7, 8, 9. Assume that each outcome is equally likely. List the outcome in 8 complement. A complement meaning that it is not in A. So A we have 5, 6, 7, 8, 9. So on the list, this list here, I'm going to cross out 5, 6, 7, 8, and 9. The complement will beat everything outside of it. So 2, 3, 4, 10, 11, 12. And then find the probability of getting event 8 complement. And there are 6 of them. Now, in the sample space, how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. To 12, and there are 11 of them. So in sample space we have 11. In that particular event we have 6. So probability of getting the event complement of A is there's 6 over 11. Of course we have the formula for probability of getting complement of A is 1 minus probability of A. Right, next, a game has 3 outcomes. The probability of a win 0.4, of a tie 0.5, and the probability of a loss is 0.1. What is the probability of not winning a single play of the game? So not winning. So probability of win is 0.4. Probability of not win is just minus probability of win. So just the complement rule. In this case we have 1 minus 0.4 equals 0.6. So winning is 0.4 or 40%, and not winning is the complement to that, 60% or 0.6. A single die is rolled twice. Find the probability of getting a 6 first time and 3 second time. Express the probability as simple fraction. So we're getting a 6 on first and 3 on the second time. So the first row we have 6, and there's only 1 6 out of 6. There's 6 possible outcomes, and there's only 1 outcome, that is 6. And same likewise for the second, there's 1 outcome of 3 out of 6 possible outcomes. So we have 1 6 times 1 6 is 1 over 36. Right. So we have 1 out of 6 to get the first one, get 6 on the first one, and 1 out of 6 to get 3 on the second time. Actually, this is a fair die, so I didn't say that, but we assume a fair die. Right. Next, a bag contains 10 white ball, 12 blue, 13 red, 7 yellow, and 8 green. a ball is select from the back, the color is noted, and then replace. So we pick out the ball, see the color, and then put it back. We do not throw it away. Right. What is the probability of select to red ball? So we want probability of getting to red ball. So on the probability of getting the first red, there are 13 red, and our that 35 out of 50. So the first red is 13 out of 50 chance to get a red, and then we see the color and then put it back. The probability of getting the second red, because we do not throw the ball away, we still have 50, and there's 13 red. So pretty much that's what we have. 13 over 50 times 13 over 50. And we have 0.0676. Right. Notice that this one we only know the color and put it back, we do not replace it. The next one is different. There are 35 chocolate in a box, all identically shaped. There are 8 filled with nuts, 11 with caramel, and 16 with solid chocolate. Find the probability. You select one randomly and eat it. So we eat it, and we do not put it back. So we eat it. That means original we have 35. When we eat it, we have 34 left. Then you select the second one. Find the probability of select 2 solid chocolate in a row. First one. So we want 2 solid chocolate in a row. To get the first solid, the 35 total. 8 are filled with nuts, 11 with caramel, and 16 with solid chocolate. So we're going to have 16 out of 35 to get the first solid. To get the second solid, now if we take out one and we eat it, that means there's only 34 left. And we eat one of the solid, so we have 15 left. So that's what we have. So let's say we have on the calculator 16 divided by 35 times 15 divided by 34. And then if we want to go to fraction, hit math, enter twice, and we convert that to fraction, which is 24 over 119. Right. So probability of getting the first solid is 16 over 35, but we ate that, so the next one there's only 15 solid left, and then 34 total. Right. Next, the manager of a corporation was surveyed to determine the background that led to a successful manager, and so this is what we have. Given the manager is a good manager, so we have the good manager here. There are 39 in total. So given that is the case, what is the probability that the manager has some college background? So some college background. Now this one is a bit confusing. If you have the college degree, then consider you have the college background as well, or master or PhD, that consider to have some college background. So that should be 5 plus 25 plus 5. But in this context, I think if we just want some college background exclusively, no degrees, there's a 5. So we have 5 out of 39. So 9 has some college degree. That is good. Manager, and divide by the total of 39. Right. This one is a little less confusing. The manager of a used car lot took inventory of the automobile on his lot and construct a table like this. A car is randomly selected. So there are 200 of them and one is randomly selected. Given that the select car is older than 2 years. Okay, older than 2 years. So pretty much that part here. Older than 2 years. And find the probability that it is not a foreign car. So foreign car is this and not foreign car. So have those numbers. So 26 plus 11 plus 22 over the total 47, 23 and 49. Right. So the top we have 26 plus 11 plus 22 divided by the bottom 47 plus 23 plus 49. And we have 0. If we want fraction, hit math, convert to fraction, 59 over 119. Right, next. The probability that a region prone to hurricanes will be hit is in a single year is 1/5. What is the probability of getting at least 1 in 5 years? Well, getting at least 1 in 5 years, if we count, could get 1 in 5 years, 2 times in 5 years, 3 times in 5 years, 4 and 5 in 1 year, in 5 years, sorry. The probability of getting just 1 hurricane in any single year is 1/5. Of course, we might have 5 of them in 1 year, but the probability of that is slim because now we only have in 1 year, probability is 1/5. Right. So there are 2 ways to do that. One way is we just count. We have 1 hurricane, 2, 3, 4, 5. But I'll do using the complement instead. By the way, I guarantee you will have one problem like this. We'll have at least on the test. Right? So at least once in the next 5 years. At least one. At least one we could have be 1, 2, 3 or 4. The complement to that is not at least 1, meaning there's going to be 0. 0 hurricane. And 0 hurricane, this is how we calculate it. There are 5 years. The probability of getting hit is 1/5. The probability of no hit is complement to that. So 1/5 is hit. So probability of no hit is 1 minus that, so it's 4/5. So for each year, there are 4/5 chance that there's no hurricane. And we multiply those 5 times. So we have 1 minus those multiplied together 4 times. Just say 4/5 to the 4th. 4 divided by 5 to the 4th power. Sorry, there are 5 years, right? To the 5th power. So 0.672. Right? So probability of getting hit is 1/5. Of no hit is 4/5 in a year. So in 5 years we multiply those together 5 times, and so that is no hit. But we want the probability of getting at least one, so we take one, subtract it, and that's what we have. Right, another at least here. Of hair corn starts 5 times, so we get once again is 5 times. If it is a fair corn, so 50% head and 50% tail. What is the probability of at least one head? So this is exactly like what we had before. At least one head. So a corn is tossed 5 times, so at least one head. So it would be 1 head, 2 head, 3 head, 4 head, and 5 head. Right, because that is at least one, and so it's up to 5 times that we toss a corn. So be 1 minus probability of getting 0 head. So 1. Probability getting no head out of 5 times. And this is a fair corn, so 1/2 chance to get 0 head after the first one, and then 1/2 on the second one. And 1 minus that. Right. Sorry, this will be 4/5. 1/2. So 0.9688. Yeah. So probability of getting no head is 1/2 times 1/2 times 1/2 times 1/2 times 1/2 5 times. Because this is a fair corn, probability of getting head and tail will be the same. 50%. Right, next. License plates in particular state display 2 letters. So first we have 2 letters. And followed by 3 numbers. Right. So 2 letters, there's 26 choice. They said repetition are allowed. So the first one may have 26, the second one also have 26. So doesn't matter what we pick first. The second one is not depend on it. And the numbers could be 0 to 9, so there are 10 choices. And multiply all of that together. This is just multiplication rule. 26 times 26 times 10 to the 3rd power. And that's what we have. So simple enough. Right. Next we have probability. Permutation and combination. Next, vice president, and secretary treasurer. So there are 3 roles. And there's our order. Three different roles, so order matter. If order matter, this is a permutation. So in particular, we're going to choose 3 people for 4 out of 14 to get some position. So enter 14 math. Go to probability, option number 3, and we choose 3 and 64. Right? Right. Of course, the reason we choose the wrong number because we should be permutation, right? 14 math permutation number 3. Alright, sorry. 2184. Right, order matters. Then we use permutation. The next one, order does not matter because we have the committee of 3. And we pick 8 names in the ballot. So we have 3 out of 8. And this one, committee, so order does not matter. And 8 math, probability, option number 3 of 3, right? 56. Right. Next, a box contains 22 widgets. 4 of them are defective. Of course, if 4 of them are defective, the other 18 are not defective. If we select 4 at random, find the probability that all are defective and none are defective. Oh, this is interesting. So there are 4 widgets. Now, find the probability that all of them are defective. So originally, there are 22, and out of those, 4 defective. The second one is we pick 21 of them left, and all 4 of them. Wait. Which one we're talking first? Let's talk about defective first. If it's defective, after we pick out the first one, the first defective out of 4, we have 3 left. And then out of 21, we have 2 are defective left. They have 21, there's 1. So there's a chance that this is the probability of all of them are defective. So on the top we have, after we take out 1, there's only 20 left, and there's 19 left. So on the top, 4, 3, 2, 1. Divide by the bottom, 22, 21, 20, and 19. Right? So you have 1. And if we want fraction, hit math. 1 out of 73.15, so we have the answer already. So that is defective. and non-defective. Non-defective, 22 that are defective, so there are 18 that are good. So originally there are 18 have 22 that are non-defective. Now if we pick one already, there are 21 left, and there are 17 defective left. And out of the remaining 20, we're going to pick one that 16 left. And finally the last one, 15. Right? Remember, originally there are 22 and 4 of them are defective. So 22 minus 4 is 18 of them that are not. So 18 divided by 22. And then we take one out. There's 20 out of 21, 17 over 21, and so on. So do all of that. So the top is 18 times 17 times 16 times 15 divided by 22 times 21, 20, and the last one is 20. Sorry, 22, 21, 20, and 19. Count properly. And if we change this to fraction, we have 612 over 1463, so it have to be this. So for defective, there will be 18 not defective, and it's still over 22. And since we take that out, there's 17 defective left, I have 21, and so on. That's what we have. Right, next, in how many ways can a committee of 3 men and 4 women are formed from 12 men and 12 women? So first, we're going to pick 3 men out of 12. So pick 3 men out of 12. And then next, we pick 4 women out of 12 women. So we're going to pick from 12 4, and I will just calculate and multiply them together. That should be easy enough. 12 math combination, pick 3 from 12. So NC 12 C3, pick 3 men out of 12, and out of 12 women, pick 4. And we have that. Right, so this is a combination because a committee, so order does not matter. Right, next we have a committee of 6 people to be selected from 8 parents and 4 teachers. Find the probability of selecting 3 parents and 3 teachers. So first of all, we're going to select 6 people from 8 parents and 4 teachers. So in this case, we will select 6 are possible 8 parents and 12 teachers, so be 12 total. So if we're going to pick 6 randomly, that gives us the possible ways. We're going to pick 6 out of 12, right? 12 math, go to probability option number 3, pick 6. That's 9, 24. So in this event, we want 3 parents and 3 teachers, right? 3 parents and there are 8 parents, so we pick 3 out of 8, and then we pick 3 teachers out of 4, right? There are 4 teachers, and we do 3 out of 4, right? 3 parents, 3 teachers. Right, 12. Sorry. 8. 8 math. And we're going to pick 3. And then our 4. We hit 3. So 224. Right? Or we can do that individually. A math 3, and then 4 mark 3, 4 times 56 is 224. So this is the event of 3 parents and 3 teachers equal to 224, and that is the number in the sample space. There are 224 different ways to do that. So the probability of getting that event is NE divided by NS, and there are 224 out of 924. Convert to fraction. 8 over 33. Right, simple enough. So randomly selecting 6 out of 12, that's what we have. And then 3 parents out of 8, 3 teachers out of 8, multiply together. And then probability, we just divide them. Right, so that we're done with all the statistic.